In this lesson, we'll be learning about the features of balanced and unbalanced force, addition of force. Just a bit of recap. Using a tip-to-tail method, what you need to do if you want to add up these three forces is that you shift one of the forces to the tip of the other force, and then subsequently you also move the tail to the tip. So this is known as the tip-to-tail method. So it's tip-to-tail, tip-to-tail, tip-to-tail. And the resultant force is, of course, from the starting rate to the ending point over here. So this green is the resultant force. As long as there's a resultant force after adding up of all the forces, the object is subjected to a situation known as unbalanced force. In summary, unbalanced force simply just means that resultant force is not equals to zero. So it must mean that when an object has a balanced force on it, the resultant force is then zero. Or a simple example of 5 Newton left and 5 Newton right on an object. So you have 5 Newton left and 5 Newton right. And of course, the net force that's on it is zero. Because if you apply the tip-to-tail method, what it means is that if I shift the yellow tail to the tip, you find that it goes back to the original point. So graphically, 0 Newton or resultant force having a 0 Newton means that the starting and ending point is the same. What about balanced force for 3 forces or more? Does it hold true? This idea can also be applied to addition of 3 or more forces. As long as you apply the tip-to-tail method and you find that the starting and the ending point are the same spot, it means that the resultant force is 0 and the object is under balanced force. So taking this example, you find that you have 3 forces that's acting on the red dot over here. And using a tip-to-tail method, you shift the arrows. And you find that after shifting the arrow, it goes back to the same spot. Then it means that the resultant force of these 3 forces is 0. Another way to think of it is that it forms a closed triangle. What do you mean by a closed triangle? Means that it goes here, and goes here, and goes here. So it forms a closed triangle. And it also doesn't matter which force you shift first. I'll use an example to show you again. Okay, so this time around we'll shift another force, and we'll shift the tip-to-tail method, another force. Again, you find that it is a closed triangle. Or again, I move this arrow, then this arrow. So again, it is going this way, this way, and this way. So it's still a closed triangle. So why does a resultant force equals 0 means that it's a closed triangle? One way to visualize it is that the resultant of these 2 forces, this A and B, over here is the orange force. So this choose these 2 forces. So by shifting it, and the resultant force of A and plus B is this orange force. So in order to counter exactly this resultant force of A and B, so that the resultant force is 0, the third force must be exactly the same magnitude, but it must be of a different direction. So which means that this is A plus B, and this is the C, which is going back to the original position. So you find that you form a closed triangle. But please take careful note of the direction of the force. It must be all tip-to-tail method. Another example. So if you look at this, if you shift it one of the arrows and it seems to form a closed triangle, but actually it's not. You find that it actually doesn't flow. Okay, this one goes like this, doesn't go like this, but this is actually in this way. So actually this is not a closed triangle, and this is wrong application of tip-tail. In fact, what you should be doing is that you should shift this arrow over here, and then this will get you it doesn't actually form a closed triangle. And the resultant force is actually this yellow arrow over here. So the resultant force is not equal to 0 actually. So this is a summary. Okay, that's all for today's lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysics.wordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.